All right, let's slowly get started. I see people in the back of the room. Maybe grab one of the chairs. Okay, welcome to ICNRG. This meeting is spanning the globe, I think. So it's in UTC time zone. I'm +8, Dave is -6, I think, and I know that Mark is there from -9. If you have someone from Australia, that would cover it completely, but I think it's going to be fine. Okay, before we start, the usual housekeeping things. We are here in the Internet Research Task Force. We follow the IETF IPR rules, disclosure rules. So let us know if there's any IPR related contribution that you make or that you see or that you are aware of in this context. And the most important thing here is the mask policy. It sounds a bit strange because we're not wearing masks, but we are just by ourselves. So we just got reminded to announce this again. Please keep your FFP2 or N95 mask up unless you are really speaking at the microphone and you cannot be heard otherwise. Okay, usual agenda hints and quick reminder, this is the Internet Research Task Force. We are not doing internet standards here, we are doing research, and the RSCs that we produce are typically of informational or experimental nature to enable future experiments and then generate some insights for the larger community. Okay, my co-chair is Dave Oran. I'm the co-chair, and before we move on, we have to find a note taker. And if you're new to this, this is a fairly light job, so we are not capturing all the presentations, just the gist of the discussions, and it is quite informal, so it's just important that we kind of capture the technical content. And it's all the other groups, we cannot move on without a note taker.
Doesn't have to be someone in the room. It can be somebody remote.
Yeah, of course, yeah.
But it can't be one of the chairs since we have to run the meeting.
Right. So while you're thinking about it, maybe just one other thing. Please use the Meet Ecolite tool, even if you're in the room, for the queue management, so that people can get your name. It makes it much easier also for the note taker. And it doesn't hurt to just say your name when you're making comments or questions. Okay.
Dirk, then I do it if no one else volunteers.
Thank you very much, Matthias. Yes, I got it. Thank you, Matthias. Okay. That's great. So this is our agenda for today. So we are going to have like 2 presentations on manifest container topics. Then one on the C4 CCNX implementation and its application to cloud native use cases. And then I'm going to talk a bit about some ideas for RESTful ICN, and then we can discuss any other business. Is there anything else that we want to talk about today, or that you'd like to change in the agenda? Okay, then let's look at our research group status. So we have a couple of documents that should be published soon. So CCN info is sent to the RC editor. I think it's not yet published. We last called time TLV, and it's now waiting for Colin to initiate the IRS3 review, I think. Flick we're going to talk about in a minute, and then we have ICN ping, traceroute, and path steering. And yeah, Dave can give us an update on this, since he's heavily involved in those.
Yeah, so as most of you know, we last called both ping and traceroute quite a while ago. It's been through IRSG review successfully. Got some very good comments from Chris Wood and a couple of other people. Those have been revved and checked back through, and are pretty much ready to go to the final stages of IESG conflict review and final IANA processing. But we've had a conversation with the IRTF chair, and because both of those capabilities for management are significantly enhanced if they can make use of the capabilities of path steering, we sort of jointly felt it would be best to progress all 3 of these to publication as RFCs together. So we're going to hold up ping and traceroute from the, sort of the final processing, although of course please go ahead with modified implementations and experimentation on those, so we can finish up path steering. Now, status of path steering is as follows. It was an individual draft for a while. It's went through a number of revisions. It's been looked at pretty carefully by people in both the CCN and NDN communities. Matter of fact, the last version had some major changes to how we do the NDN encoding to bring it up to date with the way the NDN protocols have gotten partitioned into 2 combined protocols. And a little while ago, it got entered as an RG draft. So it's fairly mature, although it hasn't been an RG draft for a whole long time. But we'd like to progress it very rapidly so that we don't hold up ping and traceroute very much. So our plea is to have everybody in the RG please look at the current draft, review it, send comments. We would very much like to last call this soon, like within the next month or so, and get that done before the holidays so that we can get it to IRSG review expeditiously and have everything wrapped up in a few months. So thank you in advance for your help on moving this forward.
Yes, thanks. So, I mean, this is, yeah, pretty useful, but also cool technology. So, I mean, path steering is a really nice feature. I think that would be really important and valuable output from ICNRG. All right. With that, I'd like to hand it over to Mark for his presentation on Flick. And let me bring your slides up. So do you want to run the slides yourself, Mark? What's the best way for you?
Yeah, I could do that. Let's see how this is going to go here. Oh, hang on, sorry. This hasn't been approved by my system before.
Actually, what I can do, I can bring them up and then give you control over it. That's maybe the best way.
Sure.
Just a moment. Sorry, I didn't realize this earlier. So now you should be able to control the slides with your cursor.
Yeah. Hey, look at that. Clever people there making that product.
Yep.
All right. So this is the Flick draft for file like ICN collections. And the active authors right now are Dave and myself, and Christian Schuden and Chris Wood have also contributed quite a bit in the past. So in this presentation, I'm going to talk about the background for Flick and review some of the history, and then I'm going to walk through the main Flick features that are in the 04 draft, and then conclude with issues that we know about for the 04 draft. I'm not really going to do a delta from the 03. I could talk about that if someone has specific questions, but I decided it was better just to go over what is Flick, since it's been quite a while since we've had this in the meeting. So the history. So Flick was first conceived long ago, maybe around 2014-ish, that time frame, 2014, 2016. The first draft was in 2017, and we're now in the 04 draft in 2022. The content of Flick is that it's a manifest, and it's meant to make it easier to use hash-based naming, which can be used for, what in CCN we call nameless objects, or segmenting large objects, or doing collections, or offloading signatures. So there's a lot of very useful features for it. It's been implemented and used, in several of the CCN iterations before. So currently, Dave and myself are the main authors. Christian has contributed, a fair bit for the, I think, 02 and 03 drafts, and Chris Wood was active with the earlier drafts. The 04 draft cleaned up a lot of the style. Ken Calvert gave us a lot of useful feedback. Hopefully we'll get some more feedback on the 04 so we can tidy it up for the final 05 that we can submit. So what Flick does is it provides a manifest of hashes, so you can retrieve all the segments of a piece of application data using hash-based naming. The hash is the manifest is hierarchical, so you don't have to fit it all in one object. And the pointers in the hash can point to either more manifests or to application data. There is a canonical traversal order, and there is metadata that could provide other traversal hints, such as for video. Flick has its own encryption mechanism. It's using standard protocols and all that, but it is specified how you would encrypt a manifest. There are also several interest construction techniques. So these are, depending upon the way that the publisher has decided to create the application data that is referenced by the manifest, there might be different ways that you construct the full name to put in an interest. And Flick has several techniques, and we could add more techniques later on. So as a manifest, using hash-based naming is very efficient because it's an exact match name. And in CCNX, that's also very important since everything has to be an exact match name. Manifest techniques have been around for a long time to distribute hashes. So this is the current, hopefully standardized way of doing it. Manifest can also offload authentication because you only need to sign the root of the manifest. A Flick manifest has one or more hash groups, and each hash group can have its own naming convention and its own metadata. So we'll talk about those name constructors in a few slides. So the traversal order in Flick we've defined to be pre-order, which is the basic top-down, left-right style of traversing a tree. A consumer, of course, can retrieve the pieces in any order that they want, but to reconstruct the original data as intended, you would follow the traversal order. Some applications might not care about perfect reassembly, and they might use metadata or other hints to skip around the content, for example, video playback. The hash pointers can point to other manifests or application data, and the publisher is free to put those in whatever order they want. So you could do all manifests first, then more data, data first, then more manifests. You could intermix them. You could put all interior nodes having only manifests and leaf nodes having only data, and so forth. It's entirely up to the publisher how they do that. There are what we call metadata and annotations. So metadata generally applies to hash groups or the overall manifest content object. And these can be things like the size of the subtree rooted at the manifest, or the size of the subtree in a hash group, the amount of, and these sizes are the application data underneath there, not counting manifests. You could have digests of that information. You could have sizes for the immediate application data children of the node. There's locators for routing hints. And so these are the metadata that we put in the draft, but it's entirely extensible by more TLV tags. Annotations can be applied to individual pointers, and the only one that we've put in the draft would be the size of the application data underneath a specific pointer, though we have tossed around ideas about video hints, but those are not in the draft. And these are the definitions of the things that I just said, so I'll skip that. Locators and name constructors. So a locator is a routing hint. So in NDN, of course, they have an explicit routing hints for interests. In CCNX, you can, if you're using nameless objects, the name of the interest is essentially your routing hint. So these can be used by both protocols. The mechanism differs, but the publisher or someone providing the content can provide the locators to use in the interest construction. How you name an interest and all the other flags that might go in the interest can be part of what we call a name constructor. So the manifest will specify the scheme that a consumer should use, based on either the locators or other names. And we've defined 4 of those that are, I didn't go into the details of those here, but they are in the draft. So a hash group is the collection of pointers, and you can, as I said, you can have one or more of those. So an example of why you might want more than one would be if, for example, child manifests are under one namespace and application data is under another namespace. So you could have a hash group, a first hash group for the child manifests and a second hash group for the child data, and those can have the different name constructors. And you could intermix these or interleave them however you want. There is a default name constructor, so if you don't specify anything, there is a default behavior. Locators and name constructors are inherited, so one could only define them in the root of the manifest tree, and then as you traverse the tree, you would just keep reusing the same values as you go. The encryption for a manifest was designed so you could do in-place encryption and decryption, and then just swap a TLV value to say it's encrypted or it's plain text. You don't have to do it that way, but it should be possible with the AES encryption that we define. We define two keying mechanism. One is a pre-shared key where there's only a key ID and a nonce in the manifest content object, or there's a wrapped key technique. And it is, extensible. You can define more, and hopefully we will get more than those two. For pre-shared keys, there's just the key ID, and it's assumed that you've either done out of band or key exchange protocol to know about those key IDs. We use an authenticated encryption authenticated data mechanism with AES encryption, all just very standard stuff. For the wrapped key approach, the intention is that this is wrapping the AES key that's being used by the pre-shared key mechanism to encrypt the manifest, so you don't have to have a key exchange protocol. And there is then just the kind of standard, for ICN, there's a key ID, the wrapped key, and a key locator for the key ID if you wanted to fetch it instead of having it wrapped in the manifest. It uses RSA OAP, and future extensions could be for full key encryption, data encryption mechanism, or for using elliptic curve. So we've defined this to be usable by NDN or CCNX. So really, Flick is a grammar and a structure and a set of techniques for using the manifest, but they would be natively encoded in either CCNX or NDN. We've provided encodings for both of those, so hopefully the ideas of this can become standardized, and you would have hopefully even standard library implementations for it between the two protocols. So in the draft, we also talk about a root versus a root plus top manifest. So this is the root manifest approach is basically as simple as it sounds, right? You have the top level manifest where you have your signature, you might have your name constructors and locators there, and then the rest of the manifest is just normal stuff. Another technique that we've described is having a root plus a top. So you would generate your content manifest, as normal, and you have the root or the top level manifest of that structure, and then you glue on a root manifest on top of that. So this means that if you want to be changing your locators or your signature or other things, name constructors that are in the manifest, you're just swapping out the root, but all the rest of the manifest stays the same. All of its hashes are the same. All of its, pushing out to caches and so forth is all the same. So that's the intention between having a root plus top versus just a plain root. Again, this is entirely up to the publisher what they want to do about it, and they could even use some other technique that isn't described in the draft. So still to be done. We have some Python prototype code that's really just about building the manifests and the trees. It's not really a protocol implementation, but that prototype is behind the draft, so we need to bring that up to the draft. Flick actually supports acyclic digraphs, not just trees, so we should have an example of that. The kind of standard example of that is you have a deduplication. So maybe you have one content object that's like all zeros, and you could refer to that content object from multiple places in your tree, if that's a common content object for your encoding. The next two are really around the nonce and salt and kind of some of the differences between the RFC descriptions of those and the NIST description. So this is more so just a note that we need to make sure that how we describe these things is clear given the standards. There were some usages of the nonce where we weren't exactly clear about how the salt and the explicit nonce get used. So we will clarify those in the 04 draft. We might also want to consider using a KDF to ensure that there's no repeated nonces between manifest nodes or entire manifest trees if the same keys are used. So that will be put into the 04 draft. We have the INI consideration section to go over. They did send some feedback on the draft, so we need to review that and incorporate it into 05. Of course, security considerations needs to be worked out more, especially since we are talking about having a specific encryption protocol in this draft. And the NDN section, I'm sure, is stale because it's 3 or 4 years old. So that needs to be touched up for recent NDN changes. And I suspect that is the end of the presentation.
Thank you, Mark. Yeah, we have
Questions, comments? Help? We could really use some help from the rest of the community to review this and contribute to it.
Yeah, as you can see, this is a really solid piece of work. Lots of effort went into it, and at the same time, it's also a very important mechanism. Right? It's any ICN application, any system that wants to share larger objects probably use something like manifests, and so it's kind of like a key part of the system. And we really want to publish this soon. I see Ken is in the queue. So Ken, what's your question?
Can you hear me?
Yeah.
Okay. Google, Chrome and I are disagreeing about whether I gave permission for my camera. So, I will go through and review the 04 draft. Thank you for the updates. And I just wanted to say I have a student who's working on trying to implement it from the 04 draft for NDN. So we may have some feedback for you on the NDN section. He has had some personal challenges this semester, so we didn't make as much progress as we wanted, but I'm hoping we can get to that early next year. But anyway, I will try to get feedback before the end of this year for sure.
Okay, that's excellent, and you can have the student contact me directly, and I'm very happy to help them along as best I can.
Great, thanks.
And I'm trying to remember whether I sent the email to the mailing list or just to the other co-authors, but there is kind of a bullet list of updates that I know needs to be made. If the student has any questions about the encryption in particular or other things, reach out to me rather than spin your wheels, because there might have just been an omission in the 04.
So Mark, are you aware of any other implementations?
Well, there was an implementation in CINC of an early Flick version, maybe like 02 or something like that. But I'm not sure of the status of that nowadays.
Okay. So I actually have an implementation myself that is, I think, maybe on the same level as the Python prototype. If anyone is interested or has a student who likes to program some Clojure, so Lisp, let me know. I'm happy to hand over this implementation. I currently don't have time for that. All right. Yeah, anything else? Any other question? Okay. Yeah,
All right.
great. Thanks,
Thank
Mark,
you.
for progressing this and for giving us the update. Let's move on. So next we have Jens Finkhäuser on the agenda. And so how are we going to do this now with the slide sharing?
You hear me, right?
Yes.
This microphone is on? Yeah. I don't know if I don't think I have control over the slides. Can you do that for me? Can you forward them? Or...
Sure.
Okay, that would be awesome. Okay, yeah, this slide is just title. We can skip that.
All right.
Yeah.
So, yeah, maybe you can introduce your work yourself. I don't need to do this. You have the floor. Thank you.
Could you skip already to the next slide?
Sure.
Thanks. Yeah. Okay. So I'm Jens Finkhäuser. I run a very, very tiny R&D company or non-profit actually in internet technology, right? So this is a building block with container format. I don't need to tell you too much about the purpose there. It's work done under NGI 0, which is managed by an Internet Foundation. And I guess the reason I'm talking here is because I'm taking a very different approach from the manifest. And when I started out, actually, the approach was to use a manifest and all that kind of thing. But then I did some parallel work for the ISAC Foundation, and that sort of influenced the design a little bit. So I mentioned them here as well, but they did not actually pay for this work. Thank you. Can you go to the next slide? Okay, so I have very different goals. My background is not on the slide, but I want to tell you this anyway. My background is in peer-to-peer video streaming. So video is a very, very high use case, high priority use case for me. Which means I want to make it streaming friendly, also to include the ability to multiplex different content types into the same resource. If you look at how Blu-ray is in terms of files on the disk, then you have different files that sort of need to be processed in parallel, and that should also be possible in a streaming context. I want to support offline first usages. Not everywhere in the world has connectivity. I don't know if you've been to the tube here. When I was last using it, this is a while ago, there was just a black hole, and you might want to do some work on something and then come back out of the tube again, and it actually merges with what you had before. Another use case that I have in mind is collaborative editing, so having multiple authors to the same resource. You can't solve this in a container format. You need something like, for example, a CRDT, which was something we're also working on. But the container format can help with this a little bit, and that's what we've tried to aim here for. It should be end-to-end encrypted by default. Yesterday I was speaking at DINERG. why I thought that was important, other than the obvious privacy and security concerns. But yeah, that was an important part for me, where I've seen some proposals say, well, basically encryption is more of an application concern. So that's from my point of view. And a very European thing, I suppose, is the GDPR. We have this derived right to be forgotten, which means content deletion was a very important use case for me, which is not something I see most of the time. And that leads to a very different design. Next slide, please. Yes. So yeah, I read through. I wasn't really aware of the details of ICN before a couple of weeks ago. I read through the RFC 7927, which is concerned with named data objects. In our case, an object name is, as I interpret the RFC, right? An object name is not just a hash. There's something else to it. I'll go into details later. Vessel does provide data origin authentication as per section 4.1. We have a partial solution. It needs more work for distributing public key information or key information in general, so that also we can deal with that part and the other sections there for what is it? Yeah, encryption and what was the other part? Doesn't matter. You know this document better than I do. Next slide, please. Okay, so alternative approaches. This is just telling you what you already know. There's a lot of this going on, that object names have a hash as an identifier. It's very elegant and robust. I really like it, but it doesn't really fit well into the goals that I've outlined in the beginning. My understanding of Flick, I've read through it as much as I could before this talk, is that it also used this. The talk just now was very useful in confirming most of this. I've looked at DMC, I've looked at a couple of others that all seem to be manifest approaches. And of course, you can get beautiful things such as Merkle trees for validating a resource out of this, which I don't have. Next slide, please. So my problem with manifests is I have a couple of problems with manifests. From the GDPR and right to be forgotten perspective, in a manifest, in order to delete something with a manifest approach, you just do not reference this anymore. That's not quite the same as deleting it. It could still exist everywhere in the network, and it's still retrievable with an old manifest, basically. I wanted to have something slightly more robust. I know I can't guarantee anything, but I can try to be a bit more robust than that. The streaming problem that I see everywhere with manifests is that you have to have real-time updates to the manifests as your resource grows. Streaming, maybe disambiguate this a little bit. You can stream an existing resource, right? Or you can live stream something like a broadcast video. And it's more the second kind of situation that I'm concerned with. And most of the manifest approaches, they're completely consistent, fine in themselves, but the idea of keeping this ever-growing manifest updated at the consumer is not really a problem of the manifest approach as such. So it needs some other solutions. When you have multiple authors and you sign your manifest, somehow becomes the question, who does the signing and at what point? I find that a little bit unsolved. Usually there's just no support for this, which is also okay, right? It's just not what I needed to go towards. And when you do have multiple authors, you also have this problem that you can create conflicting manifests that are equally valid for a given time point. And then when nodes start synchronizing, then you have to have the mechanism for merging this, and it's a new manifest, which again has to be synchronized. So I see problems coming out of the manifest approach when you have multiple authors, as well as streaming, as well as deletion. Next slide, please. So I try to get rid of the manifest, basically. And the approach is it's not particularly magical. It's just very similar to something like Git does, or even a blockchain without proof kind of thing. I just, oh yeah, by the way, these content parts, I'm calling them extents from file systems. The first one in a resource has a random identifier, excuse me, and then I just create every subsequent identifier as a hash of the parent extent identifier and the author identifier, and you have a verifiable and deterministic and also conflict-free way of just allowing multiple authors to create extents in parallel. The problem is that this, if you just don't give a mechanism for choosing the ideal parent, then you create then you end up with a tree that can be very wide. Becomes harder to merge into some consistent state later on. So I added a section on choosing the ideal parent identifier, which is based on the leaf node with the longest or most linear path. I don't know how to better explain this other than in the next slide. Yeah. So here I have, this is from my pre-draft, if you want. I haven't submitted this, or I haven't created an ID yet. As an example tree that might come out of this. Each sibling is basically must be created by a different author under the scheme, right? So you have at minimum 3 different authors in this here. And if you look at the longest paths, well, visually speaking, it's going to be it's not going to be the one that goes through node B1 at the top. But then the question becomes, is it F1, F2, or G? And that's what the mechanism is solving for you. Next slide, please. So basically, it's really simple. I mean, I'm just taking the weight of the edge between 2 nodes as 1 divided by the number of siblings. I add all the individual segments into a path weight, and that gives us a result. By the way, there's a small mistake here in the table that I've fixed in the document, but not here yet. In line 6, you have A, B2D, and then in line 7, it's A, B1D. That should be B2, and in line 8, the same thing. And then you end up having 2 equally weighted paths, and then there's a simple tiebreaker, bitwise ordering, really very simple, between the last extent identifier and that chooses F2. Next slide. So extends must be signed, but the encryption is optional. You either have a signature, a public key signature when there's no encryption, or AAD when it's also encrypted. As this RFC says, there's a key distribution challenge here. The way I'm hoping to solve this, that's not quite there, is that because I also have this multiplexing feature here, we can do some key distribution also just multiplexed into the same resource. Next slide, please. So multiplex means that the content isn't just binary data at all. It's data sections. Now there is of course a blob section for binary data, but that's just one of a few. Having this section also makes the format very extensible to other use cases. The section has a type, self-explanatory, and a topic. A topic is more of a context in which to interpret this. This also creates resource substreams if you want. So you can have a topic that's dedicated to your video content, a topic that's dedicated to your German language audio, and so forth. And you can have a topic for AAA, of course. That's not in my draft right now. I have some thoughts on how to do this, but I've just reserved the topic slot for that in this draft. And you have a content type section, which works very much like in HTTP. You define the type of the blobs that might follow in the same topic. Next slide, please. All right. editing and deleting. With this scheme, you can't really rearrange the tree, right? That's not possible. There's a permanent order to the extents. So this whole idea of just forgetting about one is not going to be viable, which is on purpose. So every extent also has a kind of version. I quote the version thing here because in the document actually I use version for two different things already. So I didn't want to introduce a third one. It's a scoped counter, scoped to the author, that the author increments whenever they create or modify an extent. And that means that actually, if you want to be precise, the object name is a tuple of the extent identifier and counter, because that gives you the specific version of the extent. And if you have that kind of scheme, then you can start updating your extent with an empty content, right? So erasing is just deleting the content section, overwriting the content sections, but keeping the extent identifier intact, and they can reassign as and update it. Next slide, please. That has an effect, because with the manifest approach, if you forget about, if you exclude a block from your manifest, if you forget about this, you can, of course, out of band notify caches that this is no longer relevant, it should be deleted. But it's very easy for a cache to just ignore this. I mean, it's easier to not add functionality than to have it, right? That's why this is actually a bit fragile for my taste. Whereas if you have end-to-end encrypted extents and deleting is nothing but overwriting the content, then a cache cannot really distinguish between an edit and a deletion. And that should make it more likely that they accept the deletion as a valid operation that they want to support, because they don't know about it. Of course, it's still possible to find ways around this. You know, a cache can keep all versions of an extent, but that incurs a cost. And I hope that helps get these things actually deleted. Next slide, please. So from the collaborative editing point of view, which is where we sort of start, or one of the angles from which we started, the container format doesn't actually solve that much, but at least it does a couple of things. In the single author use case, you don't even have a tree, you just have a single linear list of extents, and you don't have to update the manifest. So you have a slightly improved streaming friendliness there in this. In the multi-author use case, because of the ordering scheme I explained earlier, you have partial ordering. What you can't guarantee is that within a group of siblings, what the precise order of sections should be, but you can guarantee that all descendants of a particular extent come after the parent, and that can also already help with ordering things like CRDT operations. And other than excuse me, other than that, I really do think that something like end-to-end encryption and the ability to embed AAA content is very fundamental to how we want to shift data around in the world. And so I really think it should be in sort of an infrastructure thing that then the upper layers like the CRDT or whatever you're going to use there can then use. Next slide, please. Next slide, please. Right. So what we also have is nothing to do with this, is something called CapRock. It's a capability-based system with cryptography. Yesterday in DINRG, we had a talk about power of attorney. I urge you to look at that, because the approach is almost exactly the same, just independently done. That's something we worked on under the ISA Foundation grant. And really the work that needs to be done as well, but that's a separate sort of document, is to specify how we can put these tokens into AAA sections in Vessel, so that becomes part of the authorization scheme, let's put it that way, that we can send authorization information along with the data. We might, I don't know yet exactly, also provide key exchange in either Caprock or in additional AAA sections in Vessel. There's still a bit of fuzziness there, so there's definitely some future work. Next slide, please. Oh yeah, that was it. Any questions? No, not from the room. Oh yeah.
But I yeah. Rio.
Am I good to go?
Hi.
Hi, my name is Rio. I am at the University of Glasgow. Thank you for interesting talk. So the scope, I'm just trying to double check that my understanding is right.
Yes, please.
So the scope here is sort of data container to be used on a sort of ICN of some sort to bring those features that you mentioned for like write to forgotten and offline first features and that stuff.
Essentially, I mean, what we're doing is we're building our own software stack that reads very close to an ICN type solution,
Right.
And it's really for that, but it has the potential of having other users, of course. No.
So you've extracted the sort of the design, the architecture, the mechanism into sort of maybe potential as a sort of proposal to sort of say, look, this might be useful. Maybe.
Exactly this.
Okay.
Exactly this.
Okay.
It might not be useful to any of you in the room. No, I know.
Right. And so I know that you don't guarantee that right to forgotten is actually, you know, enforced, but yeah, I don't know how you approach the sort of, I couldn't fully understand how you would want to approach the have the right to forgotten and the offline kind of, well, offline first kind of use. Could you maybe elaborate a little bit about that so that I can get my head around that?
Yeah. Well, they're sort of unconnected in a sense, right? But when they do connect, it becomes interesting. You're right about that. So offline first is simply the notion that in our system we don't want to have constant connectivity as a requirement, right? So that's really it, because we have locations in the world where there is no connectivity. You should still be able to work on something, and when you work collaboratively on something, at some point this has to be merged, which is basically the same sort of problem that Git or solves for text, right? But in a you know, more broader application, if you want. The right to be forgotten is no orthogonal to this. It's just trying to take into consideration that asking a cache to delete content, or asking a cache to delete content is very difficult, because you don't know which caches are involved, and it's sort of impossible to know, right? So yeah, you can start sending hints out, maybe in a different protocol, but that seemed more complicated to me than saying, well, actually deletion and overwriting with 0 bytes, you know, is kind of the same. And if we hide the fact that it might be a different operation from the caches, then they're just more likely to go along with it. That's really the whole thing there. Past that, I can't guarantee anything. Does that make sense?
So it's a sort of a attempt to sort of allow deletion
trick caches
of the network in the context of like caches, but then obviously as a consumer, once you have it, it's yours. And that's
of course.
Tough, I guess. Okay, great. Thank you.
You can't take that away, no.
Yeah, of course. Thank you very much.
No, you're welcome.
Yeah, my question's in the same vein. Doesn't it seem to be a fool's errand to try and delete data in a large-scale distributed system? I mean, it's just like you have to assume that every bit that's ever been sent over a wire is stored somewhere. So yeah. So I really don't understand the idea that you try to delete things from caches. Caches won't have the encryption keys anyway.
A well-behaving cache is not a problem. It's always a malicious cache that's the
Well,
problem.
you have a malicious cache, but the malicious cache won't have the decryption keys. So it doesn't matter whether it's holding the bits.
That is the hopeful version. Yes, I mean I agree. As long as the cryptography holds, you're right. At that point, we don't need it. But
if the cryptography doesn't hold, none of the other stuff works anyway.
True.
Okay. One other quick thing you might want to look at, because it seems to be working towards some of the same goals you do, is a system called Secure Scuttlebutt.
I know it. Yeah.
Hmm?
I know it. I mean, I don't know every detail about it, but I do know it. Yes.
Yeah, it seems to have the same distribution properties as your system. That's why, partial ordering, single source, chain data,
It has similarities.
horizons, all that kind of stuff.
Yep.
Great, thank you.
Thank you.
Okay.
Okay.
Other questions? Then, yeah, thank you very much, Jens.
No worries.
So, yeah, we do this from time to time, say, having presentations, say, in the broader context of, if you like, information-centric systems. And it's also sometimes quite interesting to, understand their particular constraints. And we just mentioned Scuttlebutt, which we discussed earlier. So let's keep doing this. But now we come back to, say, a core ICN topic again, and we have Hayamizu-san talking about ICN as a service using the C4 implementation. And let me bring this up.
Hi, thank you for introduction. I'm Yusaka Hamis from NHT Japan. Today I talk about C4, CCNX-based cloud-native network functions for deploying the ICN as a services. So could you please the next slide, please? So this is the outline of my presentation. And first I'll explain the motivation and the background, and we introduce the C4 and the CFPICO, which is developed by the NICT, and mainly we try to integrate C4 with the Docker platforms for deploying the ICN as a services. And we explained some sample scenarios, and finally conclude my presentation. So next, please. So a dozen years has been passed since the original concept of the ICN is advocated. The concept is changing a network from the host-centric to the content-centric. And the ICN is currently forked to the several concrete network architectures, CCNX, as specified in the IETF and the NDN, named data networking by the NDN project. And actually, we, NICT, are developing the CEFO, which is compliant with CCNX 1.0. And CEFO is an open source software platform and enabling the CCNX-based communications. And so far, there's lots of research is about the routing and forwarding and the caching, and security has been proposed by several many research communities of the ICN. But one missing piece might be deployment solutions of the ICN modules into the existing internet infrastructures. So next, please. So in my presentation, first I will introduce the CEFOR, which is an open source software platform for enabling CCNX-based communications, and also the CEFPICO, which is application development tools. And then we try to integrate the CEFO with the Docker platform, and for easy and rapid the deployment of the ICN. So we'd like to introduce a method for easily deploying the ICN as a microservices and quickly constructing the ICN-based networks. So next slide, please. So now I will introduce CEFOR CCNX-based extensible packet forwarding engine and the CEFOR. So next, please. So CEFOR stands for the a CCNX-based extensible packet forwarding engine, and which is compliant with CCNX 1.0. And so it is originally designed in 2016, and 6 years has been passed, and it can handle the interest and the content object forwarding and caching. And the source code of the CEFOR is previous slide, please. So source code of the CEFOR is open in the following URL, so you can download it from the web page or GitHub. Okay, thank you. Next slide, please. So CEFOR sets us following 3 design policies: find the lightweight and usability and extensibility. So most important thing is lightweight implementation. So the software platform should be usable for the resource-constrained devices such as a sensor node. And also, depending on the situations or network requirements, we need to extend it. So the platform should be easily extensible to accommodate novel functions to satisfy the future network needs. So next, please. CEFOR has to realize these policies. So CEFOR has pluggable architectures. So as you can see, the CEFOR consists of the 2 core daemons called the CEFnet-D and the CS Manager D. CEFnet-D is a packet forwarding engine, and the CS Manager D is a caching engine. So depending on the situations, in the case that you require the high networking performance, you need to prepare some high-end machines such as routers and enable the CEFnet-D and the CS Manager D, and with some various plugins. So you can deploy the full ICN stack node. But you require the lightweight implementation, such as the Raspberry Pi implementations. You just enable the CEFnet-D with some minimum plugins. So researchers can install necessary ICN functions depending on the situations and their requirements, machine requirements for considering their machine resource constraints. So next, please. Next slide, please. So the CEFOR sort of package. So now CEFOR is ready for providing the Orion package for the CCNX-based communications. I mean, the core daemons of CEFnet-D and the CS Manager D with the extensible plugins and consumer utilities and the producer utilities. And also, we provide a network management tools, CCN info. So this is a CEFOR Orion package. So next slide, please. And also CEFPICO. CEFPICO is a CEFOR Python compact package, and which is open in the following URL. So, and CEFPICO is a Python-based wrapper program that helps developing the CCNX applications. So, and it can enable easy coding of the Python programmers compared to the original C language. For example, you want to send the interest packet, you need to write the 33 lines in C language, as shown in the left figure. But by using a CEFPICO, we can reduce it to the 4 lines. Just import the CEFPICO library and just create a handler and just call the send interest packet. So CEFPICO is a very user-friendly implementation. So next slide, please. Now I will introduce main and Docker integrations. So what is Docker? As you know, the Docker is a very famous platform for container-based virtualization technologies for the quick and scalable development of the network services. So there's some features and benefits, lightweight and performance and scalability. So The most important point is Docker doesn't have the OS, so it is very lightweight, and you can enrich the evaluations of the scenarios, and you can facilitate the comfortable tests of the developed ICN services, and also scalability also. So next slide, please. So this is just a simple example scenarios of the Ceph Docker-based networking. So in this scenarios, a consumer download a file from the producer. The producer responds to the request and send back the data, and the CCX router, so called CephNet-D, stores a list of data into the CS, such as a CS manager D. So this is a very simple scenarios. So next slide, please. This is how to writing a Docker file. So, but I'll skip my details of the this how to, Docker file. But just the important thing is we define the three services. One is a base services, which is a base functions as I say node. And the next slide, please. And we use a minimum function serving as an ICN node, that is installation and application preparations. And next slide, please. And also, we need a cache services, so you can define the cache services as following the Docker file. So we totally use a there's three type of the Docker file and there's three type of microservices. So next slide, please. And also we leverage the Docker Compose tools, which is very useful for defining and running the multiple containers Docker applications. So it's very easy configurations. We're using a YAML style file as shown in the right figure, and it can create and starts all the services from the configuration with a single command. So in my experience, it's very easy to conduct scenario-based evaluations such as emulations, like network simulations such as NL3. So as shown in the right figure, so in this example, we define the producer services and my router services and the consumer services. And each service built it from the cache or the minimum images. So next slide, please. Okay. Now I'll show some sample scenarios. Next, please. So this is a video streaming use cases over the internet, and we NICT held the ICN summer workshop last year, which is held in a fully online style, and we demonstrated the multicast video streaming using several Docker platforms. And in this demonstration, the producer is located at the NICT Tokyo, and the consumers are around in Japan, and received the video streaming from their home or schools or companies. So what is important here is that all the participants, including the beginners, such as bachelor students, can construct the ICN node on their laptop, and they can receive the video streaming successfully. So this is very, I think this is very comfortable. Ceph-based ICN networking is very comfortable and useful for especially for beginners, and which is very kind and comfortable for deploying the ICN network over the internet. So next slide, please. Yeah, this is my conclusions. So in the future work, we are now pursuing a possibility of a collaboration with the emerging Docker orchestration technologies such as Kubernetes, and we believe that this Ceph Docker-based networking can be one possible options for the easily constructing the ICN networks over the existing internet infrastructures. So thank you for your kind attention. This is my end of presentation.
Okay, thank you very much, Mrs. San. Do we have questions?
Yeah.
Leo.
Hi, thank you very much for the interesting talk. My name is Rio from University of Glasgow. So you mentioned using this on a sensor node.
Mhm.
What kind of sensor node? Have you looked into running it on a real hardware? Have you tried it so far? I'm just curious about sort of using Docker-based system on the sensor node. I don't know what kind of like power scale you're talking about. So I just wondering.
I introduced Cepho is running on the sensor node, such as a Raspberry Pi, but I never tried to the Cepho Docker integration in the sensor node, but it can be used and the Act because Cepho Raspberry Pi is a very what should I say?
Capable, I
Capable
guess,
to
right?
construct very Docker is very lightweight, so it can be easily act.
So the if you're talking about sort of the kind of modern Raspberry Pi with like quite powerful ones that's the kind of the baseline at the moment of sensor node we're talking about.
Yeah.
Okay, thank you very much.
Thank you for your questions.
Sorry, one more question.
Oh, okay.
You said only one package, but
Yeah.
then you also said that you can have subset of it to make it more lightweight to adapt to less powerful devices. Are these only one as in like there's one binary that contains everything and you switch it on and off, or you have like a lightweight binary that you create for the cases of using on a
Yes.
low storage device? Is it the former or the latter?
Oh, sorry. What is your question?
So I'm wondering whether you have one binary that has switches, or are you building for smaller ones for the sensor nodes?
Yes.
Okay, so the latter. Okay,
Yes,
thank you very
yes.
much. So which one is it? Is it the first one or the second one? The first option is the switches. So like a command line option.
Yeah.
Okay, that's
just
okay.
switch. Yes.
Okay, so it just switches then.
Yes.
So okay, so in which case then the full size binary is used everywhere, including the little devices.
Oh, no. Just sorry. The later one is right. So for building the Cepho, Doctor, could you back to the Dockerfile constructions slide? So when building the Cepho, previous one, please. Yeah. So as you can see, when configuring the Cepho and building Cepho, we can configure what you want to use as an option, enabling the cache function and HTS manager functions. So you don't have to building all the binaries.
So then you could effectively have a smaller binary to run on smaller devices with a smaller storage capacity. Okay, great. Thank you very much.
Okay, we have one more question from Ayub Bissou.
Thank you for your presentation. My name is Ayub Messous from Fujitsu Research of Europe. Very, very interesting work indeed. My question, you mentioned the video streaming use case. So what was the difference between like normal video streaming like application?
Such as HTTP or some other video streaming applications. So thank you for your question. So in ICN, the routers can act hop by hop manner. So and they can do the in-network. They can provide in-network functions such as caching and such as transcoding or something, or some intelligent function is can be equipped with each router. So and loss recovery of the packet is also, so we can enhance the quality of the streaming quality compared to the conventional HTTP or some other approach. I think this is.
Have you tried to compare the performances that you achieved using your API?
Not yet. Yes, not yet.
Thank you very much.
Okay. Any other question? Thanks again for spending your work. Really interesting. And let's move on.
Okay, thank you.
Yeah, thanks a lot. Okay. Yeah, this talk is about a few ideas how we can build relevant applications with ICN and the protocol mechanisms that we know. And yeah, obviously one important application is the web. And so Dave and I put some, say, initial thoughts together. The background is that, so we submitted this as a so-called statement or vision paper to the ICN conference in September. And this is like a short 2-page paper, so it doesn't take a long time to read it. And so this was somehow put in a context of metaverse, and so wasn't really presented at the conference, but appeared in a panel, which was fine. But so we thought it could be interesting to actually present the idea and get a bit more feedback and maybe also kick off some work here in the group. The other background is that currently there's lots of talk about quick HTTP3 and so on, and so here's an interesting blog posting by Bruce Davey, who is characterizing Quick basically as the say long missing RPC mechanism in the Internet Protocol suite, so for efficient RPC communication. And so not casting it not as a TCP replacement, but more like an RPC system, which TCP isn't really good basis for, in his view. And so we tend to agree. And when you talk about web communication, you have like two elements. So you need something like efficient, say, RPC style communication, but you also need something that is typically called REST. So some kind of state evolution on servers and clients, and then some protocol framework to manage that. And so whereas Quick is, say, admittedly much better than, say, the previous protocol stacks, it's so the approach that we take in this paper here is that, okay, can we maybe improve it even further with a data-oriented design? So quick reminder or intro to REST. The idea is that you have clients and servers, and you have say, well-defined protocol mechanisms that allow you to, say, set up state on a server, and then via interactions modify the state and, say, evolve it both on the server and the client side. And so in reality, yeah, HTTP is stateless, but you need some mechanism to refer to this state in your interactions. And so in reality, we use things like cookies, for example, to identify clients, and then indirectly also the client state in RESTful communication. And if you look into the like state-of-the-art systems, so you could say they are not quite as optimal as they could be. So first of all, there's something like implementation complexity. So you have several layers of stacks with their interactions. So several protocol layers in the stack. And on the other hand, if you look at the interactions, say using like modern HTTP3 communication, of course you have quite a few messages going back and forth, and you have request parameters, cookies, and so on. And so the key idea for HTTP3 and QUIC is, of course, that you have the quick connection context and then potentially several streams in there. And so we thought, okay, maybe we actually have a very good tool to come up with a, say, even better approach. That tool is ICN, of course. And so we thought, okay, what would we need for building a platform for RESTful communication, and then by extension, maybe for future modern web protocols. And so what we want to do is, say, do REST communication in an ICN idiomatic way. So not, blindly copy all the interaction or message flows, but think what is really needed. So for REST, you would have clients and servers in a session. So it's you could say, yeah, it's an implementation of this larger concept. You need some understanding of the state evolution, and of course, it needs to be applicable to many different applications. Yeah, you cannot ignore security and privacy. So if you want to use this for any, say, relevant application, you want to have, say, similar security features as HTTP and TLS today. But so can we do this better than like HTTP3 over QUIC today? Can we simplify the protocol machinery? Can we maybe even have less overhead on the wire without losing all the nice ICN features that we appreciate? And okay, so if you kind of start doing this in a naive approach, you would say, yeah, well, we have interest data interactions, so we could just map the, say, HTTP or REST requests onto interest packets, and then we get data back, and we could invent some naming scheme, perhaps even some URI-like naming scheme, and so on. So we have discussed this earlier. This is not really a good idea, right? So because, as we have seen earlier, in this client-server communication, you typically have to transmit lots of data. So you need to negotiate keys, you have context information, cookies, all these things. You really can't stuff this into interest packets, right? So we have this flow balance concept, and we use interest, something like the equivalence to X in TCP, acknowledgements in TCP. And so that would kind of screw up this concept. We would have uncontrolled, not controlled data in the network. Also, if I can send, say, any large blob to any server, is not really good from a security and robustness perspective. So you open up the door to computer overload attacks and so on. Then also in ICN, well, our interest data interaction is kind of controlling things like interest rates on the client. So it operates on a network timescale. So we kind of time out these interests eventually, and this triggers, say, retransmissions and so on. When I do an RPC-like communication, well, I really can't predict how long the server takes for the computation. So these things operate on a different timescale. And then also I need some say, other security concept around this. And so we have talked about this in the context of reflexive forwarding and RISE, where we proposed a mechanism where a say client can initiate say RPC-like requests, but then we use ICN idiomatic interest data in the opposite, so reverse direction from the server, without exposing any client identity. And so it's an ICN forwarder extension that is needed there. I won't go into this today, but we talked about it, I think, last time. And so the design that we came up with is basically about enabling this client-server communication with a series of request-response interactions in a session context. So like in HTTP, you can say. We employ reflexive forwarding, so directly for RPC communication. And so allow all kinds of parameter passing. And we also apply this to the key exchange that we are going to talk about in a minute to set up these sessions. And what we want to do is this RESTful communication, but not, say, inside connections or tunnels. So the, say, response data that we get should be ICN data objects. So they, of course, would be encrypted in most cases. But we apply the usual ICN security mechanisms, and we don't want to use any tunnel mechanism. And so, of course, when you do this and you want to have good performance, so comparable to HTTP, you have a series of requests in a session. You want to avoid setting up context state again and again. So this shouldn't require more round trips. And so the challenge is that we want to establish and maintain this shared session state in these sessions. So what we do is we use the key identifiers in this session, and so the associated security context that we set up in the negotiation phase to identify the session state. And then we use the reflexive forwarding parameter passing for clients to refer to a previously created application state. And this, you could say, emulates something like HTTP cookies. And of course, when you do this, you have to think about, so what is kind of the, say, root of the shared application state. So we decided that we tie it to the key IDs. And so because this is kind of an essential, say, agreement that the client and server have to establish. So it seems to make kind of sense to use this basically as the session identifier. The drawback could be that well, if you change keys, then or if you rekey, then you have to reset up your context. In this system, you have some kind of coupling or binding between client and server, because the server has the security context and, of course, also the application context. So you have to make sure that your say subsequent interests reach the same server. This is a kind of maybe a bit something to take care of in an ICN environment, or you need to implement some kind of server backend state transfer or state synchronization system for that. So Mark and colleagues earlier specified CCNX key exchange, so in a draft here as well. And what this does is basically TLS 1.3 like key exchange between two peers that is basically following what TLS 1.3 does for establishing a shared forward secure key, which you could use for confidential communication. The main use case at the time was something like a tunneling scheme. So you can have wrapping inner ICN communication in an outer TLS-like context. So for applications like, telebanking or something, you would show any kind of commercial thing, you would use it. And so it was designed for these client-server scenarios, but in the end, you still have interests and data, so it's orthogonal to reliability and congestion control. And so what we did here is we used this exchange protocol, but we don't want to use this, say, tunneling approach. So in this paper, we kind of describe how we are now implementing the CCNX key exchange part with reflexive forwarding. So because we wanted to avoid sending interests in both directions, so we wanted to do it in the reflexive forwarding, so in our view, more ICN native way. So that's one part. And then we basically derive a key for encrypting the data objects later in the session. Maybe a bit too intricate to go through all of this right now because we are also a bit running out of time. Yeah, I would like to refer you to this paper. And I mean, this is a first idea, like a sketch essentially, and we haven't really implemented it yet. But what we think is that it's now a really good time to think about web over ICN. So clearly, it's not enough to say, well, we just use interest data. And so the key idea here is to leverage this, what we think really useful work on key exchange, couple it with reflexive forwarding, and then use it for a data-oriented ICN communication. And so we roughly approximate the capabilities of like HTTP3 over QUIC. But if you do this correctly, the resulting system implementation may actually be simpler because we don't have this relayer approach. We can leverage some ICN optimization. We have all the other ICN benefits still, like caching and in general a name-oriented system. So it could be potentially easy to implement. Of course, the devil may be in the detail. And so we think that could be a really interesting basis to build like the next generation of ICN systems. Admittedly, there's some work to think about. So, I mean, one issue here is, of course, name privacy. So that's not solved by this approach. So there are some other proposals for dealing with that, but we haven't really spent a lot of work on this. And so what we really like to see is like someone picking this up, trying to build it, and so that we can do some further experiments with it. Okay, that was our quick heads up on RESTful ICN. We don't have much time, unfortunately, for questions. It'd be great if you have questions, if you could direct them to the mailing list. And before we close, so Dave and I, I'm not sure if you were aware, there was a side meeting on Monday at the IETF in London on networking for metaverse, so distributed AR, VR applications. And a bit of the mind share there is actually going in the ICN direction. So, and I also presented, say, some ICN ideas in that context. And so we thought maybe now it could be a good time to say in this group here, think a bit about a research agenda and also recapitulate a little bit what we have in terms of technologies, things like multi-destination, multi-forwarding and multi-pass forwarding, and what is potentially missing. So for building these, say, richer social AR/VR applications. And so we thought it could be good and nice to have an interim meeting in the not so distant future, perhaps end of November, beginning of December. So if you are interested in that, please feel free to talk to us. Of course, we will also send a message on the mailing list and yeah, see what it's kind of try to negotiate the interest there. All right. Anything else we need to talk about? Thank you very much for attending and hope to see you all very soon. Goodbye. And thanks, Matthias, for taking notes. So Jens, I see you you joined the queue. We are 4 minutes above our time limit.
No, sorry, I just pressed the wrong button. I didn't have a question.
Okay. Okay. Have a nice rest of the day. Bye-bye.